boom. Hello and welcome back to Calculus 1. After the technical issues, we are somewhat back in the game. So let's see. I did lose a few of these lectures, so we'll rebuild that. But exam 2 review list, which I wrote last time, is gone as well. So I'll just steal from your notes. Exam 2 is on chapter 3. You are looking at about 10 problems, right? Most likely no parts to these problems. And the entire summary for the chapter 3 would be mechanics of taking derivatives, plus tangent line, and then plus related rates. So this is the entire chapter is these three things. Now we start with limit definition of the derivative. You must memorize the formula. Limit h goes to 0. Well, f prime is f prime of x is limit h goes to 0 of f of x plus h minus f of x over h. So that would be the formula. Then we have all the basic rules, the shortcuts, right? So basic rules, which includes plus trig, plus inverse trig, plus exponential, right? Plus log. So those are all the basic rules. Then we have product plus quotient. Then we have the, I'll write this in red, chain rule. Guys, most of the derivatives we take are chain rules, so yeah, it's red. Now, implicit differentiation. Number 6 is the logarithmic differentiation. Number 7, related rates. That's the word problems. And I'll just make sure that this actually, you know what? I'm going to start on the side. All of these include tangent line problems. So for tangent line, you know that you have to take the derivative to find the slope. Well, that could be chain rule, could be implicit, could be logarithmic, could be anything. Yes.
What did you say last time that we had to memorize? Like two things? I mean, no, two things. Yeah, we'd have to memorize. Maybe that inverse. Just sign it direction.
All right, let's take a look at problems. If you have any problems that you would like me to solve, today I solve your problems, tomorrow you solve mine. It's even trade. Yes? So function is 8 sine x plus 3 cosine x. Yeah. And you're looking for the derivative of this.
Well, the
y prime.
Yeah, y prime. So the derivative is 8 cosine x minus 3 sine x. These are two functions that are separated with the plus, so each one is independent. The rule that we use, we don't write it, but the rule we use was that the derivative of f of x plus g of x was the derivative of f of x separated. You can have plus minus, then the derivative of g of x. So they're separated because there is a plus. So you can have, 500 of different functions. Each one is done independently. If you have them multiplied, then it's product rule. If you have one plugged into another, it's a chain rule. But if they're all in the same function, separated by pluses and minuses, you do each one independently. And you see that the derivative of cosine is negative sine, so that positive 3 changes into negative 3. We copy constants as well, so that's that. Next question. Yes?
Can you do, it's 7 root x minus 9 root y equals 5.
7 root x minus 9 root y equals
5.
5.
Implicit differentiation.
Implicit differentiation. Beautiful. ddx. So for implicit differentiation, the first term is the square root of x. I'm taking the derivative in respect to x, so there will be no chain. The chain is dx dx. That cancels. So I have 7 over 2 root x minus 9 over 2 root y, and then followed by the chain dy dx, because I took the derivative of y in respect to x. Derivative of 5 is 0. It's a constant. All I need to do now is to solve for dy dx. So 7 over 2 root x is equal to 9 over 2 root y dy dx. Multiply both sides by 2 root y. So 2 root y times 7 over 9 times 2 root x is dy dx. 2's cancelled. So you can just say dy dx is equal to 7 over 9 times the square root of y over x. Or you can rationalize x. It doesn't matter. This is one of the forms or the answer. Anything else? You had the question?
Yeah. Find the derivative of x to the square root of x.
So the function is y equals x to the square root of x. Let me just make sure that the stream is going. Stream is going, good. Is anyone following the stream right now in class at the same time? So if it cuts out, please let me know, because obviously the network issues are making everything crazy. So guys, when you're taking the derivative of a function raised to a function, use log. So we are going to ln both sides, and that will drop this root x down, allowing us to do the product rule. So ln y is equal to root x times ln x. And now we take the derivative and we utilize the implicit differentiation. It is called logarithmic differentiation because we log both sides. So 1 over y dy dx, I took derivative ln y in respect to x, so I have to follow by the chain. On the other side is a product rule, so copy the first, derivative of the second, plus copy the second times derivative of the first. All the derivatives on the right were in respect to x, so no chains there. Y will go to the left, sorry, from left to right. So that's original problem, which was x root x times root x divided by x plus ln x over 2 root x. Now you can probably simplify this more, find common denominator and so on, but there it is. It's factored, ready to say equal to 0 to find more stuff on the in chapter 4. Yes, sir.
Y equals 4x sin x.
The derivative. So what are we using here? Product rule. So we see that we have two functions multiplying each other. Call this one f, call this one g. So copy the first, derivative of the second, plus copy the second times derivative of the first. The only thing we can kick out is 4. And we have x cosine x plus sine x. Bueno? So that was the product rule. Yes?
4x to the 5th minus 5x to the 4th plus 3.
Hold on. 4x.
4x to the 5th.
Okay.
Minus 5x to the 4th. Plus 3. All in parentheses to the 26th. And then chain rule. 5.
Nice. So this is behaving like everything was t to the 26th, let's say, right? Whose derivative is 26t to the 25. And t is this all of this mess inside. So it's going to be 26, copy everything to the 25th power times, by the chain rule, the derivative of the inside. That's 20x to the 4 minus 20x to the 3, and then there is this plus 3 is 0, right? So now when you take a look at these two terms, you can actually kick out 20x cubed. So 20x cubed would make this 518, no, 58, sorry. The hell, 52, 520, there we go. 520, 4x to the 5, sorry, 520x cubed, 4x to the 5 minus 5x to the 4 plus 3 to the 25, and then over here we kicked everything out, it's x minus 1.
That'd be it. That'd be the answer.
I hope you're not disappointed, but that's it. Yes.
Other than like the limit definition of a derivative, like to define that on the exam, is there anything else that you would like us to define like we did on exam 1?
Well, if there is a gift question, it would be state the only formulas that you know. There's nothing other than, right, you have the formula for product rule, formula for limit definition of the derivative, formula for quotient rule, formula for chain rule. Did we cover any other formula? We have the formula for inverse trig functions
With the equation for the
and the tangent line, yeah. Yeah, that's the inverse, yep, that's the inverse trig, yeah. So there is maybe, there's less than 10 formulas in the entire. So if there is a gift question, it will probably be that, and the form is 5 of those, 2 points each, no partial credit on missed formulas. So that will be the gift. Obviously, if you don't know, usually I don't put that stuff unless I already used up everything else, right? Because if problem number 3 is a product rule and you don't know product rule formula, obviously you can't do problem 3. So losing additional 2 points over the formula for product rule doesn't help you or hurt you, because you already missed a 10-point question, right? So you know, looking at all of this, you know, that's what it is. Any other questions, concerns?
Can you spell the tangent real quick?
Yeah. Which one?
Yeah, I don't care anymore.
Me neither.
And then y equals x squared plus 4, and then the point is x equals 4.
See, we have to have that understanding, because tomorrow I'm not gonna walk in and say do whatever, you know. I bring the problems. Today you bring the problems. All right, tangent line. What's the procedure? First thing to do is take the derivative. Very good. So dy dx is equal to 2x. So now when we plug in x equals to 4, then it becomes m equals, and we get 8. So x equals to 4. How much is y?
Plug in 4, so you get
Yep.
16 plus 4.
So we have that m is equal to 8, and the point is 420.
So you do y equals 30.
Mx plus b, plug everything in.
I like the y minus y1 better.
What is that?
Perfect.
Y minus y1.
Just another
You
y.
can use, one is called slope intercept, the other one is called point slope. They all do the same thing. I'll do both. Eight times 4 is 32. B equals negative 12, and the final answer is 8x minus 12. So that was that. Now some of you, instead of using the mx plus b formula, might use y minus y1 is equal to mx minus x1. Again, whatever you prefer from algebra, because this is calculus, right? I just need the equation of the tangent line at the end. How you're going to do the algebra piece in the middle, I don't care. So 20 is the y value for the point. Yep, to get the y value. So now we plug everything here. We get y minus 20 is equal to 8x minus 4. And that's y equals 8x minus 32 plus 20 when you move it. 8x minus 12. Same. So whatever algebra makes you happier, that's what the calculus is all about. You being in your happy place. I know, funny. All right. So that was one of the tangent line problems. Remember that for tangent line problems, your derivative could be implicit differentiation, could be logarithmic differentiation, could be inverse trig one. Anything could be in the tangent line problem, because it says take the derivative, and all of these are derivative techniques. Any other question? We can do probably 15 of them. Do you have the problem?
I can find one.
All right. So the next one will be related rates problem. All right, bye. See you next week.
Alright, I have a problem here.
What does it say?
The area of a circle increases at a rate of 1 centimeter squared
So the area,
per second.
1 centimeter squared per second. See, that so it clearly said that the area increases at the rate. As soon as you see the word rate, that's the derivative. everything happens in time. So whatever is the concept they're talking about is d, that concept, over dt. So the area was increasing at the rate, therefore dA dt. We also see from units, centimeters square is area divided by time. So this unit here must correspond to the variable here, which is area, and the bottom one has to correspond to the bottom one. So that's basics. Next one.
How fast is the radius changing when the radius is at 2 centimeters?
So radius is 2 centimeters. Look at this. How fast is the radius changing? The word changing is, again, change is the derivative, and then how fast? Well, things happen with time. So they're asking for dr dt. This over here you read as how fast is changing. So now we know it's a circle, and we know that the concept used is area. So what is the formula that we should use to solve this problem? Pi radius squared. Good.
Now you're going to take the derivative of that.
In respect to?
The radius of
In respect to?
dA.
Time. Because I have to get over dt over dt.
You get dA dt. Okay.
So dA dt is equal to 2 pi r dr dt.
And the dr dt comes because you're different variables, right?
I'm taking the derivative of r in respect to time, so followed in the chain because we have the dimension mismatch.
But it's squared. It's here.
The derivative of r squared is 2r, right? Like x squared is 2x. Cool. So now we just plug everything in, right? We have 1 is equal to 2 pi, r is 2, and dr dt is what they're looking for. Awesome. So dr dt is 1 over 4 pi centimeters per second. Now, was this decreasing or increasing? Did I say anything?
No. Is that expanding circle?
Expanding circle, which means positive. So it's growth. So radius grows at this rate. You can write the sentence. Radius grows at 1 over 4 pi centimeter per second. Because it's growth problem, right? It expands. You can also shrink, right? In which case, you put negatives everywhere. It will be -1, and then that negative will propagate and become -1 over pi over 4 if you shrink.
Where did the 1 come from? Is that the initial radius?
They gave us that in the text. The first sentence says that the area is increasing by 1 centimeter squared. So that was given in the text.
What geometry
For related rates I did, you have volume formulas for prisms, for spiky, and sphere. So you know them all. Geometry of the flat surface, like the 2D, is only areas and perimeter. Perimeter had all sides around, area of the triangle, you know, square, rectangle, circle, you know the geometry formulas. So something that people usually slip on is they don't memorize the sphere, which is, you need to know the volume and the surface area of the sphere. Those are the only two that give trouble. The rest is the boxes and stuff, x times y, easy.
What's the sphere? Is that 4/3, 4/3?
4/3 pi r cubed, because volume, right? 3 dimensions. Square is 2 dimensions, which is area. The surface area would be 4 pi r squared for sphere. The sphere
Outside of it?
Yeah, the part which contains. So how much paint do you have to use? Well, 4 pi r squared will tell you what the surface area is, and then you know how much paint you use. Just like when you can calculate area of the of the square.
Dude.
Oh, come on.
Dude.
We messed it up.
Check it out.
Did I mess it up?
I don't know. Check it out. I think you did.
Yeah, I did.
Ah.
Might be. Yeah. It's not English class, it doesn't matter.
The damage is done.
This is done.
No, yeah. Bury is one on.
Is it one on?
Is it one?
I was so sure of it too.
Yeah. Is it one?
Bury with two R's is to have burrs. Bury with one R is to hide it for something.
Okay.
Right
So it was correct.
Wait, then what is this step?
No, the one with two is to have burrs. That means I don't know what a burr is. It means to have it.
Oh, thank you.
Huh?
It's like the opposite of a pitch.
Maybe.
Do we have any other problems? 1 hour left.
Oh, yeah.
Yes.
Okay, what about this one?
He's got it.
Are you looking at the same problem I am now? It says,
Probably then.
apple best equals sine.
Like I only need themselves.
You're on page 210. Should be on page 221. Yeah, we did. I'm looking at 12. Oh shit! Yeah, I wouldn't know how to answer that.
What happened there?
F of x equals sine to the negative 1 out parentheses e to the sine.
Like this? Good.
Alright, so we gotta find the inverse of sine first.
So what is the formula for the derivative of inverse sine? It is 1 over square root of nope.
I don't know what that for you.
What do you mean? This is tomorrow. You have to know the formula.
All of them memorized, that's nice. Square root of minus. I've been focused on the
1
chain.
over square root of 1 minus x squared.
There we go.
Can we move this? See you tomorrow.
Yes. So I think 9:30, 9 o'clock is the earliest, I think.
No, I definitely don't want to have no tests, but
So you finally figure out is this, right?
So that's the formula.
Is this what you figured out?
Yeah.
Okay. So you can't use this formula because this formula only this formula only applies for the derivative of inverse sine of x, but you don't have that. You have the whole function in there. So you have to use the enhanced formula. What the hell? You have to use the enhanced formula, which is going to be the u prime over square root of 1 minus u squared.
Oh, yeah.
Right? Where this whole thing is u. So what do we get? We get that the derivative is equal to u prime, which is e to the sine x times cosine x, because the derivative of the sine x in the exponent is cosine x. So that was the chain rule part. And then divided by the square root of 1 minus e to sine x. Awesome, right?
Is that the answer?
Right, disappointed? That's it.
For our, the u prime, which is e to sine x, you did
Cosine x. The whole thing.
E to the sine x cosine x. What?
No, I know, but how did it's the change
Okay.
rule, so
That's very
you write e to sine x, and then the derivative of what? Sine x?
Yeah, of the exponent, because it's not x.
Okay, so only way to do it? Because I would have just.
That's it.
So you can't take e to the sin x and put that where x squared is, and then take the derivative of e to the sin x and multiply by that.
That's what I did. See, there's a 2 there. E to the sin x squared is e to the 2 sin x because the exponents multiply.
So what's that u on the top? That's what you mean.
Well, that is the chain rule, because this formula here is for sine inverse of x, but you don't have x here. You have a whole function, and I call that function u. So you have to, so instead of x, you have u, but you have to multiply by the chain rule, and that's the u prime. So the whole thing over here is the u prime, which is the chain rule, because this is not x. And then because it was complicated, right, you have times cosine x, then the chain rule from taking derivative of e to the sine x.
So that it was a chain rule inside of a chain rule, basically.
Yes,
Okay.
it's a double chain rule in this particular problem, yes.
Okay, that makes sense.
It's a double chain rule.
That's
All right, next one.
X cubed plus y cubed equals 18xy, and then write the equation for the tangent line at the point 9, 9.
At the point? Oh,
Beautiful problem. Tangent line.
so you're at dy,
Very good.
in the d over dx.
No, the product rule, right?
So dy
Product
over
rule.
dx equals d over dx.
So 3x squared plus 3y squared dy dx is, on the other side we have the product rule. Copy the first, derivative of the second, plus copy the second times derivative of the first.
So now you got to
So now you could go and solve for dy dx, but that would just be a waste of time and energy. Plug everything in immediately. So 3 times 9 squared plus 3 times 9 squared m is equal to 18 times 9m plus 9 times 18. Now, depending on how good you are with math, you can maybe see that you can divide everywhere by 81.
I think it was just like,
Because each one of these has 9 times 9. Each term has 9 times 9. 18 is 2 times 9, and then you have another 9. So, you actually have 3 plus 3m is equal to 2m plus 2. So m is equal to -1. And you have a 0.99. Pick your poison to get B. Y equals mx plus b. So there's the tangent line.
When you did 18x dy dx, that was just because the derivative of y was 1 and you just didn't write it? And you
Yes.
did dy dx?
Well, yeah, you follow by chain rule because you took derivative of y in respect to x.
Yeah.
So there's a chain rule. So copy the first, derivative of the second, plus copy the second, derivative of the first, 18x is 8.
yeah.
That was a product rule. Good. Anything else?
That was good.
That was
I
good.
took that off the homework, and I just confirmed that was right.
Anything else?
Cool, dude. It's a really interesting story. Really, really dope.
I don't know if we're gonna get this on the test.
I'm doing math.
Should I still ask you?
Hey, you know what? Just because
I'm looking at this section right here.
Yeah, I don't know. I think I'm gonna leave that for
Yeah.
All right, next question is really, really good.
You know you're gonna need this.
We are supposed to find the derivative of x to the pi plus pi to the x. It's a really good question.
I just take the pi to the x plus what?
Wait, while they're figuring this
It's
out,
just
you
too,
just go like a half a step back
It
up.
should be just two separate derivatives and then you just
Very good. Two separate derivatives. We have two functions that are separated. Now, what are the types of those functions? So which rules are we going to use? There is a much more confusing question, which I'm going to write after this one.
What is pi? Pi is a pi minus constant. Pi is a constant.
What did you say?
Pi is a constant.
Pi is a constant. Good.
Pi x to the pi minus 1.
Very good. So the first one is a polynomial rule. N x to the n minus 1. So the first derivative is pi x to the pi minus 1. And how about the second one?
So ln
X pi to the x minus 1.
Nope. It's not a, you can use that's only for polynomial-like problems. This is exponential-like, where the base is not e. So,
oh wait, it's pi over x. I mean, it's pi to the x. Yeah, that's it.
so it's pi to the x
That's all it's
times ln pi. Because the base is not e.
That's a rule, right?
Yep. And then there it is.
What rule is it?
The rule for was, yeah, it was somewhere we learned the derivative of e to the x is e to the x. The derivative of e to some function is e to that function times function prime. And then the boss rule, if you remember, that's how I called it, was when you have any base b raised to any function. So you copy as is times the derivative of the function times the ln b. Now our function was x, so its derivative is 1, so we didn't have to do the middle part. But ln b was still there because it was not e, it was pi.
I just saw that today.
Yeah.
Really confusing.
Well, it's,
The last one's the one you can use for anyone, right?
yes, the last one is the one that always holds, and it collapses onto the previous two if you pick e as a base and x as a f of x. The one that I wanted to ask you is technically the same thing, which is x to the e plus e to the x, right? So I actually had this problem once on the exam, and everyone just copied as is, almost, yeah. But x to the e, how do we deal with that term? Yes. And then you copy this one because this one is itself. Nice. Good questions, good questions.
What about that would be the derivative right there? Just that.
What happened?
That would be the derivative.
Yeah, that's the answer.
So whenever you have e to the x power, you can just always copy it the same way.
Mm-hmm.
And then whenever you have, like, let's say if you have x to the p, x to the power p, whatever that. To bring it down, you would just be ex p minus 1. You just always take that variable.
Well, that's the guy, guys. That's the difference between exponential and polynomial. You have to get onto so polynomial, like we have x squared and then exponential. We have 2 to the x. So over here you had your x to the pi, x to the e, and over here you have pi to the x, e to the x. So depending where the variable is, if the variable is a base, it's a polynomial like, so the rule for that is nxn minus 1. And if it's exponential wise, it's going to be b to the x ln b. Right? So you have to distinguish between these cases. You ask yourselves, is this polynomial like or is this exponential?
So
That's the first thing.
if it's constant, it's exponential. If it's a variable,
Yeah.
it's polynomial. Right?
So the only reason you didn't put a ln because e is already ln.
Yeah.
E represents ln, right?
Well, no, it's still there, but we don't have to write it because if b is e, then you have ln of e, and that's 1, right? So it collapses.
Okay.
Let's test your. Let's test what you learned. What's the derivative of e to the pi?
Pi is 1.
No, dude. It's e pi of.
So you just e pi.
Because it depends on the exponent, whether it's a
Polynomial.
Wait, hold on.
Wait. Oh, one.
No, it's e to the pi.
That's what I'm saying. I think it's e
Yeah,
to the
it's
pi.
Thursday.
Yeah.
It's e to the pi. Answer.
Fork.
If I guess long enough, I'll be right.
So what's the derivative?
Yeah.
0. Nice.
Why?
It's a constant. The hell? Smack yourselves, all of you, except n. E is a constant, pi is a constant. Go in your calculators, type e to the pi, you get a number. Derivative of that is 0. Troll.
You're not gonna take points off. That's a question of the test.
No, I sometimes on the Calc 1 exams I put the derivative of e squared. Ooh. It's a constant.
What do people put 2e?
Well, 2e to the 1 or all different kinds of things. E is a constant, is a number. The derivative of 3 is 0. Derivative of a quarter is a 0. Derivative of square root of 2 is a 0. Derivative of e is 0. Derivative of e to the x is e to the x, because e to the x is a function. E is a number. So don't discriminate. Be nice. Right?
Sorry.
Can you just write e is 2.71 next time so we know?
Oh yeah. Oh yeah. Exactly. If I wrote this in its approximate form, you guys would get it right away, right?
Yeah.
Oops. Right, all of a sudden, oh yeah, clearly 0. Right? Obviously 0.
But there's great symbols.
I know, there are letters, right?
Alright, I have another problem.
Alright, let's see. Another problem.
Alright.
Let's go.
Alright, d squared times y over dx squared.
Oh, that's the second derivative. Okay.
Yeah. 3x squared plus y squared equals 3.
3x squared.
Plus y squared.
Oh.
So wait, hold on. Before
This
you
is
start,
the second derivative of implicit differentiation.
Wait, before you start, 3 is a constant, so it goes to 0, right?
Yes.
Alright.
It's 6. I think.
Hold on.
If I can't even get this, I feel bad.
So we first find the first derivative. Not even close. So we're taking the derivative, we get 6x plus 2y dy dx equals 0. Right?
Yeah.
From here, we say that the dy dx is equal to negative 3x over y, right?
How did you get that?
I just solve for dy dx. Right? Move 6x to the other side, becomes negative, divided by 2y, 6 and 2 cancel.
Oh, yeah, yeah.
Cool. So now I need to take one more derivative here because I need second derivative. So that's a 6 plus, and now I'm taking derivative here, which is 2, and this becomes now second derivative. And from there, is negative 3.
Good thing you asked that.
Good thing you asked.
Yeah.
Put 6 of these tomorrow.
Alright. That'd be great. That'd be
Yeah.
awesome. That would be bad.
Yeah, and they're easier to grade too, so
Yeah. So everyone wins, right?
Wait, you're
Except you
wrong.
get 0.
You're wrong.
All right.
Wait,
So we
you're
have
wrong.
to
You're wrong.
we have to find the second derivative.
No, you're wrong.
what? He's putting into the homework.
I put it into the homework and you're not correct.
What the hell? The answer is not correct. Oh, I know what.
Well, wasn't it 6 over 2?
You know what's wrong?
Sugar mistake.
You know what's wrong?
I don't know what's wrong.
Product rule.
Oh, that's why it's so.
Yep.
Wait,
As soon as you say it was wrong, I looked at what the hell, and then I've seen the product rule there.
can you do that for our tests?
All right, let's go. So first what I'm going to do is I'm going to
So, wait, so 2 will be F and then Y will be G? Or 6x will be F?
no, this is F, this is G.
Okay. Oh, dy and dx is G?
Yep.
Oh, that's weird.
So
dy over dx, same thing as y prime, right?
yes. So this is 2y prime. Sure. So let's go. Derivative of 6x is 6 plus copy the first times derivative of the second plus copy the second times derivative of the first. But remember, I'm taking the derivative of y in respect to x, so I have another dy dx there. Equal to 0. And now, each one of these dy dx's is negative 3x over y. So 6 plus 2y d squared y over dx squared, that's the second derivative, plus we have dy dx squared, so that's 9x squared over y squared, and times 2, so it's 18.
Wait, where did you get the 9 from?
This one times itself, because this one plugs in here and this one plugs in there.
Gotcha.
So negative 3x times negative 3x is positive 9x squared, and then times 2 is 18x divided by y squared. And all I need to do now is to solve for the second derivative, which is going to be negative 18x squared over y squared minus 6. And then I multiply both sides by 1 over 2y to get rid of that on the left. So when I multiply here, I get negative 18x squared over y cubed minus 3 over y. Much better.
What should be 9? Negative 9x cubed over.
Would it? Yes. It would be negative 9. What the hell? Yeah, looks like batteries in. I have in my bag. It's just I need to turn around. Now, what you can do to work on this further is you can find the common denominator. So negative 9x squared minus 3y squared over y cubed, right? And let me see the original problem. 3x squared plus y squared is 3. Oh. Factor out negative 3. You get 3x squared plus y squared over y cubed. And look, that 3x squared plus y squared is 3. So this is actually negative 3 times 3 over y cubed. So the answer is, it's really cool, negative 9 over y cubed. Nice.
Easy. Yeah.
Oh, no, I don't have the one to check.
Oh,
I used the last one to show.
What does the problem tell you?
No, it was that.
Is that?
Yeah.
9 over 1.
Yeah. That's a lot of work. That is a lot of work.
Didn't you all just say you wanted this one?
Lots
Don't put this one.
of
Yeah, right? I mean, okay.
lots of chances to make
Fine,
mistakes.
I'm okay with that because I know how to do it. I don't mind doing the work.
You should just put a problem up that you think is going to help us tomorrow.
Don't worry.
Like, not the exact one, obviously, but like
It's something I don't know. It won't be anywhere.
Yeah.
something you
Just to look at it like,
Exactly. So it's this.
Shall we look?
Huh?
Shall we look at this problem on the bottom, number 8?
Yeah, we're not differential equations.
I know. This is just a comment that the problem was a lot of work.
okay,
See problem number 8?
okay.
And all you need to do is to solve that problem. So this is how solution looks like. You assume the solution. This is, you learned this in Calc 2.
Yeah, I was about to say, it's time to talk.
And then you plug these substitutions in. Then you simplify everything. These dots over here, we are skipping some algebra in between because those are the unnecessary steps. And then you get your recursion equation over here, which once simplified, there you go. That all goes in there. Once simplified, you can finally start solving cases. And then when you solve all the cases, you get your solution, which is the infinite series at the end. It's completely useless. Calculator, nothing can do there. That's completely useless. So that's the problem with a little bit of work associated to it.
That's true. Ours doesn't look nearly as
So
bad.
it's possible to do, like, get to a level where you can't use your calculator or find answers.
That's already Calc 3. Calculators become completely useless. Linear algebra, all of these courses, you can do some rudimentary stuff on them, but none of the, I mean, you already can't integrate on your calculator and so on. You would have to use your cell phone with apps. But then when you are, as you are getting higher, you know, even Wolfram Alpha starts, you know, into, you can't use just the basic Wolfram Alpha, you know, you need to know how to program it to solve certain things. So it's getting, you guys are, you know, slowly getting there. You have maybe another one. This is the last course when you can use your calculator efficiently because of graphing, understanding area under the curve. It's already becoming useless in Calc 2 with integration and sequences and series, but most of the stuff can be verified and done on the calculator to make sure everything is cool. Calc 3 is just done. Your calculators don't graph 3D at all. These TIs, whatever, and you know, all the calculations in that class are basic. I always had the joke because as far as I can remember, when I took Calculus 3, the highest number I've seen was 81. It was 3 to the 4th. That's the highest number you work with. Everything is addition, subtraction, multiplication. It's the concepts that you are learning in Calc 3 that are different.
So when do people actually apply this stuff, like, above, like, this level?
Well, it's all for physics. So my lecture yesterday for differential equation that I gave to Calc 2, where I show the, but it's on YouTube, you can watch it. All of physics, which leads into engineering and chemistry and everything else, is derived through differential equations, and differential equations are all solved using integration and power series. So
You can become like a data scientist or a computer programmer. I'm going to use any of the stuff at all, right?
Data scientist, that's like most statistics major.
yeah, most likely not. This is not the stuff for this is so Calc 2 is for electrical engineering and computer science if you're doing the programming side of it. Calc 3 is all of the mechanical and electrical engineers and civil engineers, all of that stuff is Calc 3. Differential equations, again, electrical, mechanical. Zero of that material in Calc 3 and differential equation goes for computer science. Zero. But then linear algebra, everything. Linear algebra and discrete mathematics, those are your courses for discrete.
I can see how discrete math links with computer science.
Yeah, it's algorithms. You learn how the logical thinking, and so discrete mathematics for algorithm side, which is what they call the lower end programming, and then linear algebra is for higher end programming. If you don't understand linear algebra, how to deal with matrices, which is the rectangular array of numbers, those are your arrays actually and stuff. That's what your Google is, and your MP3 compression and JPEG and all of these things are actually applied linear algebra. So you have to have both of those courses if you want to be the higher end programmer and stuff.
You know, the data science is a high demand for that. It's like they give me like 120 pages.
Any other questions or concerns for exam tomorrow?
Yeah.
We have another 30 minutes for the review.
Yeah, data science you have to get a master. Yeah. For that 120K, you're gonna have to get a master. But it's so much work. But he said it's so much money. There's a whole new demand coming for it right now.
Yeah, because that's how businesses analyze things and make decisions.
Exactly. Wait, Professor, I was actually gonna ask you this question. For finance and business analytics and information technology, do you think I need Calc 2 or Calc 1 is enough? Or am I gonna be taking more than Calc?
Wait,
For finance and business analytics? information
I
technology?
think Calc 1 was the requirement. Yeah. Anything else? Yes.
F of x equals 3 secant, well, inverse secant, so -1.
I'm actually keeping my
Parentheses tan e to the x.
All right. This is a really cool question. This is a really cool question. We can solve this by using the chain rule, right? So we need to know first what the inverse secant formula is. We know tangent, right? Secant squared. Now inverse secant, if you remember, was 1 over absolute x times x squared minus 1. 1 minus x squared. Do we recall this? Let me find derivatives of inverse trig. There we go. And there it is. On the bottom left in red, 1 over absolute x root of x squared minus 1. So, x squared minus 1.
Yeah, you were right the first time.
We cannot use the formula in this form because it has a function, call it u, over here. So we have to use the enhanced formula, which is u prime over absolute u, square root u squared minus 1. That's the enhanced version of the formula.
So when you have the chain rule inside the chain rule, you do your u prime first.
So all of this is u.
Yeah.
And when I take derivative of it, there will be another chain because of e to the x.
Yeah.
Yep. So what's f prime? It is the derivative of tangent e to the x is secant squared e to the x times e to the x as a chain rule. And then on the bottom I have, oh, there's a 3 in front. I almost forgot that. On the bottom we have the absolute value of tangent e to the x times the square root of tangent squared e to the x minus 1. Yeah, because that's what the formula says. This is u, so copy it in, right? You copy it in and square it.
Wait, that's it?
Why, disappointed?
No, I thought you were going to take out the square root from the denominator or something.
Nah, it's just a whole bunch of messy work for,
So you can just leave it like that? And that would be
yeah,
perfect.
for these inverses, yeah.
Okay.
Anything else?
Which inverses you say that we need to memorize? Secant and tangent.
Sine, tangent, and you can do secant, and then all others are easy then. Because if you know those three, the other three are minuses. Anything else?
You should give us a hard one, like anything we should do.
Yeah, which one? I'll bring it. I'm bringing stuff tomorrow. Today it's your. Today I answer your questions. Tomorrow you answer mine. As I said,
I know
even
that.
trade.
I was just trying to get the sense of it today, so now I have to be ready for it tomorrow. But it's all right. Give you a nice one right now.
Give you a nice one right now. It's like a revenge. I can still modify the test.
This is like the velocity problem. Are you gonna have that type of thing in the test?
Could if you want to.
I don't want it, but I don't know if it's gonna be Do you want to bring it up there? Because this is long.
What?
Matching heights. A stone is thrown from the edge of a bridge that is 48 feet long. Well, 48 feet above. Do you want to bring it up there?
Yeah, let's see. Sounds like a cool problem.
I was gonna either do the matching heights or velocity of a car. This one looks pretty cool too.
Matching heights. All right, guys. So they give us the formula for the stone, which is negative 16t squared plus 32t plus 48. Now, by the way, when you give me the formula like this, I immediately know this term, it tells me it happens on Earth. This term tells me that initial velocity was 32. And this term tells me that it was thrown from the height of 48. That's all encoded in the equation, all of the important features. It says, if the second stone is thrown from the ground, then its height above the ground after t second is given by so if a second stone is thrown from the ground, So guys, this is what we have. For whatever reason, there is a bridge over ground. All right. So this is the bridge level, and this is the ground level, and they are 48 feet apart. Rock number 1 is thrown this way, which is dropped, right? And the rock number 2 is thrown from the ground and it's going to go down. So the rock number 1 has the equation of this, and the rock number 2 must have equation, that's G, again happening on Earth, plus we are trying to figure out which velocity we need to use, and since it's thrown from the ground, the height is 0. So we need them to hit the ground at the same time. So determine the value of V0 such that both stones reach the same hold on. Something is wrong here. Question makes no sense. How can... Oh, okay. Scratch the picture. Guys, the rocks go this way. You throw the rock from the bridge up, and it's going to fall on the ground. And you throw the stone from the ground, and they want it to reach the same height. There we go. So what velocity needs to be used for them to reach the same max? Well, we know that max occurs when we take the derivative, right? So we can find by figuring out f prime of t, which will be negative 32t plus 32, set that equal to 0, and that gives us the max, but it gives us actually the time. Time to max. Max height. It's a really cool problem. So t is 1 second. Right? You move 32 to the other side, becomes negative 32 divided by negative 32. Negative 32 divided by negative 32 is positive 1. So now we know that at 1 second we are reaching the maximum height with the first stone. So now we find the derivative of the second stone, which is, I forgot the square there, or maybe I put it, the computer erased it, negative 32t plus v0 also needs to be 0 but we know that, yeah, it makes no sense to have the same initial velocity. Determine the value of 0 such that both stones reach the same high point.
Is it at the same time, or does it has to get to the same point?
Well, I never calculate. Let me calculate first the high point. So the high point, f of t, is negative 16 times 1 squared plus 32 times 1 plus 48. And that high point is 16 plus 48, 64 feet. So the high point for the stone, which is the maximum height, is 64 feet at the air. So now you know that the second rock needs to reach that height. So you can figure out when that happens by you need to reach 64. So you need to reach 64 negative 16 t squared plus v0t. So that's one equation, and the other equation is the derivative equation, which is g prime is equal to negative 32t plus v0. So we have these two equations, and we need to figure out what v0 and what is the time at which. So the time is 1. Oh, we don't need the second equation actually, because we have the time is 1. Because if the object travels faster, it covers more distance at the same time. So we don't need the second equation. For time equals to 1, we have a 64 is equal to negative 16 plus v0. So v0 is 80 feet per second. There we go. Awesome. Nice question.
Thank you, Professor.
You're welcome. Any other questions, concerns? Okay, question. Oh, question. All right. So I'll see you tomorrow then at the exam. Stream, bye.